Hello everyone. Today we are going to be doing the physics quiz for week 8, I believe. So let's start. Question 1. Person is pulling a box along a rough floor using a rope parallel to the ground. The tension in the rope is 25 newtons and the box moves through 2 meters at a constant speed. The work done by the frictional forces. So they want work. We're going to write down the rule for work, which is work is equal to force times distance. Work is equal to, we are going to look in our question for the force, which is right here, 25, and the distance is 2. Now, since they asked us for the frictional forces are resistive, which means they are going to be negative. So it's going to be negative 25 times distance, which is 2, which is negative 15 joules. And that's our answer. That is question 1. Question 2. For this question, you need to understand motive and resistive work. So basically, motive work is when the force and the movement are in the same direction. Resistive is when movement and force are in opposite directions. So this is what you need to know for this question. Let's read them one by one. Weight of the box as it slides down an inclined plane. We are going to draw our inclined plane. This is the box and it is sliding down. And the weight is vertically downwards. In this case, the weight and the movement are in the same direction, downwards. So weight is going to be motive. But if we draw the second case, which is the second part of the question, it is being pulled upwards. So this is the movement. And weight, weight is vertically downwards. In this case, weight is opposing to the motion since weight is downwards and a movement is upwards. So weight is going to be resistive as it is opposing the motion. Now for the other two cases, which is friction on the box as it slides down and friction as it is pulled up, friction is always resistive since it always goes against the movement. It is in the opposite direction of the movement. So that's it for this question. Question 3 now. A block of mass 2 kilograms initially moving at 10 meters per second is subjected to a force of 3 newtons applied to the displacement, opposite to the displacement. When the block is displaced by 5 meters, its speed given to the nearest integer becomes. Now, for this question, we are going to use the work energy theorem. What the work energy theorem basically is force times distance is equal to half mv squared final minus half mv squared initial. Let's substitute in our values. Force, we're going to look at our force. 3 newtons, but it is directed opposite to the displacement. Opposite means it's going to be negative. Times distance, they told us displaced by 5, is equal to half times mass, which is 2, times velocity final squared. So this is what we're looking for. After it is displayed, how much displaced, how much is the speed? It's this value. We don't know it, so it's going to be x squared minus half times 2, which is the mass, times initial velocity, which is 10 squared. Now, if we do this on the calculator, we are going to get that 1 over 2 times x squared minus 1 over 2 times 2 times 10 squared. Then we are going to solve for x, and we will get that x is equal to 9.219, which if we round to the nearest integer, is going to be 9, and that's our answer. On to question 4 now. Question 4 is just memorization. You need to memorize when is energy transfer present and when there isn't. On to question 5. A block of mass 6 kilograms is released along a rough horizontal surface with an initial speed of 8 meters per second. During its motion, the block is subjected to a constant frictional force of 12 newtons. How far does the block go before it comes to a complete stop? We are going to use our rule again, which is force times distance is equal to half mv squared final minus half mv squared initial. Force they told us it is a frictional force of 12 newtons, so it's going to be negative 12 times distance. This is what we're looking for. How far does the block go? So we don't know what it is equal to half times mass, they told us it's 6 kilograms, times velocity final squared. Now here in the question they told us it comes to a complete stop. So final velocity is going to be 0 squared minus 1 over 2 times 6, which is the mass, times initial velocity squared, which is 8 squared. Now this term is going to completely cancel out, but you can put it if you want to, if you want to follow the rule exactly. So we're going to end up with negative 12 times x is equal to negative 1 over 2 times 6 times 8 squared. And then if we solve for x, we're going to get that x is equal to 60. And that's our answer. On to question 6 now. Question 6 is relatively simple. We started off with 100 joules at position A. At position B, it is 75 joules. How much energy is lost? We started off with 100 and it's 75, so it's 100 minus 75. What's the difference between them? It is 25. And that's our answer. Relatively simple question. Question 7. In an isolated system made of two interacting bodies A and B, energy gained by A plus energy gained by B is equal to 0. This is just a definition you need to memorize. Isolated system, or otherwise called closed system, the total energy gained by A and the total energy gained by B always has to be equal to 0. Energy is conserved in an isolated system. On to question 8. Energy is being transferred between two interacting objects, A and B, in a closed system. Object A loses 30 joules of energy. We're going to write our equation, which is A plus B is equal to 0. Now they told us object A loses 30 joules, so negative 30 joules plus B is equal to 0. We want B, the amount of energy gained by object B. We're going to take this to the other side. B is equal to positive 30 joules, which is our answer here, 30. Question 9. Energy can be transferred from one object into another when a force moves the object through a distance. This is just a definition you can memorize. Underline the name given to the energy transferred by a force along a distance, work. This is also just pure memorization. Definition of work. A man pushes a car by exerting a force of 100 newtons on it. He pushes the car for a distance of 10 meters. We're going to use a rule. Work is equal to force times distance. Work is equal to, our force is 100 times our distance, 10. Work is equal to 1000 joules. And that's our answer. On to question 12. This is what we explained earlier in question 2, I believe. The work done by F on the box. We are going to look at force F and the motion of the box. They are both going into the same direction, so it is motive. If they are going in opposite directions, it is resistive, which is the case in the next question directly. So this is motive, while this is resistive, as motion is to the right, while the force is to the left. So this is going to be resistive. On to question 14. Force F of magnitude 20 newtons is exerted on a box, causing it to move along a horizontal line as shown below. The force makes an angle of 45 degrees with the horizontal. What is the work done by the force after moving the box a horizontal distance of 10 meters? Okay, we're going to write our same equation. Work is equal to force times distance. Now they told us distance is 10, so work is equal, right here. Work is equal to force times 10. Now we need to find the force. In our case, the force is a bit diagonal, as you can see. But in the question, they told us it moves along a horizontal line, which means it is only moving to the right. So we need to break down our force into components, the y and x components, and the force we are going to use in our equation is only the x component, which is what's causing the movement. So let's draw this triangle here. This angle they told us is 45. Okay, so basically what I did is that I extended this okay? And then they told us that the force is 20, so this is 20. And we are trying to find this force, right? This part, since it is the x component. So this is going to be cosine of 45 is equal to the adjacent, which is our x component, over hypotenuse, which is 20. So our x component is going to be cosine 45 times 20, which is going to be cosine 45 times 20, which is 10 radical 2. So we're going back to our original equation. Work is equal to, we found that the x component, which is our force, is 10 radical 2 times the distance, which is already found to be 10. So 10 radical 2 times 10, which will give us 141.42, which if we round is going to be 141. And that's question 14. On to question 15. A car of mass 1,600 kilograms accelerates from rest under the action of a net force of magnitude 800 newtons. The speed of the car after moving a distance of 100 meters is then equal to. We're going to use the work energy theorem. So force times, let's write it a bit more up. Force times distance is equal to half mv squared final minus half mv squared initial. Let's sub in our values. Force, they told us, is 800. So 800 times distance, they told us moving a distance of 100 is equal to half times mass, which they told us 1,600, times velocity final squared, which is what we're looking for, the speed of the car after moving a distance. So this is what we are looking for, minus half times mass, which is 1,600, times initial velocity, but they already told us it started from rest, which means initial velocity is 0, which technically means you can cancel out this term entirely. So we are going to end up with 800 times 100 is equal to 1 over 2 times 1,600 times x squared, which if we put on the calculator is going to be 2 times 1,600 times x squared, and then we solve for x. We're going to get that x is equal to 10, which is our answer right here. On to question 16. Two bodies P and Q form an isolated system. After an interaction with Q, the energy gained by body P is plus 50. We're going to write P plus Q is equal to 0. P, they told us, is plus 50, so plus 50 plus Q is equal to 0. We want energy gained by Q, so we take this to the other side. Q is equal to negative 50. That's our answer here. And then they asked us for the net change in the energy of the system. Since it is an isolated system, the net change is going to be 0. This is just memorization. Net change is always 0 in an isolated system. That's question 16. Question 17. The work done by the normal reaction. Okay, let's read the question. A block of wood is sliding down a rough inclined plane. Let's draw our inclined plane, right? Making an angle of 30 degrees with the horizontal. So this is 30 degrees. The mass of the block is 2 kilograms. Let's draw the block. Okay, it's a problem with my, okay. It's 2 kilograms. And they told us the force of friction acting on it is 3 newtons. The block moves along an inclined plane through 6 meters. Take G is equal to 10 meters per second squared. Choose the correct answers. Okay, the work done by normal reaction. Normal is always vertically upwards, right? Now they told us that it is only sliding down the rough inclined plane, which means it is not, so it is, direction is only to here. It is not moving upwards. Since there is no distance covered, no movement, the work done by the normal is going to be 0. Since distance is 0, normal is going to be 0. Okay, so that's it for part A. Now on to part B, which is a little bit more complicated. So let's draw our diagram again. We said this angle is 30 degrees. Now, the work done by the weight of the block. Let's draw our block, which is right here. and they want the weight, which is this force. Now we are going to write work is equal to force times distance. Once again, work is equal to, now we need to find force and we need to find distance. Force of weight, W is equal to mg. So we can substitute the force by mg, and we already have m, which is the mass, 2 times g, they told us is 10, so 2 times 10 times the distance. Now this distance is this distance right here. This is d. We're trying to find this distance. So work is going to be equal to 20 times d. Now let's take this triangle on here. Second, there's a problem in my pen. Okay. Let's take this triangle right here. We have this is 30, and they told us that it slides down 6 meters. So it's, let's say it started here and it ended here. This full thing is 6 meters, and we are trying to find this distance d. If we look at it, we're going to realize that it is the opposite, and we already have the hypotenuse. So sine 30 is going to be equal to d over 6, which means that d is going to be equal to sine 30 times 6, which if we do on the calculator is going to be d is equal to 3. So 3. So we're going to substitute d in this equation by 3. W work is equal to 20 times 3, which is equal to 60, which is our answer here. Now a simpler way you could memorize is work done by weight is equal to mgh, and then you would substitute in mass, g and h. You would need to find the same way we drew our triangle and so on. So that's it for part B. I hope it was clear. The work done by friction, we're going to write the same equation. Work is equal to force times distance. Work is equal to, they told us that force of friction acting on it is 3 newtons. So it is 3, but since it is friction, it's going to be negative 3 times distance, which is 6 meters, which is going to give us negative 18. And that's our answer for question 17, which I believe is the most complicated question in this quiz. Question 18. A parcel of mass 2.5 kilograms is lowered vertically down by a string through 0.6 meters. The tension in the string is equal in magnitude to the weight of the parcel. Take G is equal to 10 meters per second. Now for this question, we are going to find, we need to find the work done by gravity. So work is equal to, once again, force times distance. So in this case, work, there's a weird problem with my pen today. Okay. Anyways, work is equal to force. We need to find the force, which is basically weight. In this case, the work done by gravity is going to be weight. So it is going to be mg, right? So mg times the distance, which they told us down by a string through 0.6 meters. So W is going to be equal to the mass, which is 2.5 times 10 times the distance it got put down by, which is 0.6. And if we do that on the calculator, 2.5 times 10 times 0.6, we are going to get 15 joules. And the work is motive because if we draw let's draw it out. Okay, this is the string and it is being lowered down. So this is the direction of motion. The work done by gravity is also vertically downwards. So they are both acting in the same direction, which is vertically downwards, which is why the work is motive. Now, the work done by the tension in the string on the parcel, they told us here that the tension in the string is equal in magnitude to the weight, and we already found the weight is 15. So the work done by the tension is going to be opposite the work done by gravity, so it's going to be negative 15. And it's going to be resistive, since if we draw it again, it is moving downwards, and tension is pulling it upwards. They are opposing each other, so it is resistive. So that's it for question 18. I hope it was clear. On to question 19. The work done by the gravity on the pendulum over one complete oscillation is large. Basically, what you need to understand here is that this pendulum is swinging back and forth. Now, we said work is equal to force times distance. In one complete oscillation, as we can see here, it starts from this position, it goes all the way to the other side, and then it goes all the way back, which means that overall it went back to the same position. So distance is 0, which means that work is going to be F times 0, and anything times 0 is 0. So work is going to be 0. So the work done by gravity is 0. The work done by the tension, it's the same thing. Since there is no distance, it's going to be 0. And the work done by the air resistance, in this case, air resistance is going to be, air resistance is a form of friction. And as we said before, friction is always resistive, since as it is swinging from right to left, air resistance is going to be opposing the motion, so it is resistive. That's it for this question. Question 20. A net force is pushing a 1.5 kilogram toy car across the horizontal floor through 4.5 meters. By the end of the motion, the car's kinetic energy has quadrupled. Its initial speed was 2 meters per second. The initial kinetic energy, okay, we know the rule for kinetic energy is half mv squared. So we're going to substitute in our values, half times 1.5 kilograms, we get from here, times initial velocity, they told us it is 2 squared. Now if we do this on the calculator, it's going to be half times 1.5 times 2 squared, which is 3, which is our answer right here. Now the work done on the toy, we're going to use the work energy theorem. Basically, if you notice, then force times distance is equal to half mv squared final minus half mv squared initial. What this says is that the work is equal to kinetic energy final minus kinetic energy initial. So basically, the change in kinetic energy is equal to the work. So we're going to use that in this question in part B. They told us the work done on the toy car. Now, the work is going to be kinetic energy final minus 3, since we already calculated initial kinetic energy, 3. And they told us here, by the end of the motion, the car's kinetic energy has quadrupled. Quadrupled means times 4. So the final kinetic energy of the car is 3 times 4, which is 12. So the work done is going to be kinetic energy final, which is 12, minus kinetic energy initial, which is 3. So work is equal to 9, which is our answer right here. And then they told us, assuming the net force is parallel to the displacement, the magnitude of this force is, for this question, we are going to use work is equal to force times distance, right? We are looking for the force. So we're going to take distance to the other side. Force is equal to W over D. We already know work, which is 9. So force is equal to 9 over distance. And they already told us in the question right here, moves through 4.5 meters. So 9 over 4.5, which will give us 2. And that's our answer for question 20. A toy car is projected across a rough floor. As a result, the kinetic energy of the toy car is halved over a distance of 5 meters. The initial kinetic energy of the toy car is 4 joules. Now, as we said in the previous question, work is equal to final minus initial, right? Kinetic energy, of course. Now, in this case, we're looking at the work done by the friction on the car. at the beginning, final, they told us that, if we reread the question, the result is halved, which means that the kinetic energy final is going to be 2. It went from 4 joules, its initial was 4, and it went to 2. So it's going to be final, which is 2, minus initial, which is 4, which is going to give us negative 2 joules, the work done by friction. This was a bit confusing, so I'm going to repeat. We are going to use the fact that work is equal to final kinetic energy minus initial kinetic energy. Now we know that work is equal to final. They told us that as a result, so finally, the kinetic energy of the toy car is halved. And its initial was 4. So its final kinetic energy was 2. Its initial kinetic energy was 4. So the work done is going to be negative 2, which is our answer. Now for part B, we're going to use W is equal to F times D. They want the magnitude of friction, so basically the force. So we're going to take D to the other side the same way we did before. So work over distance is equal to force. So force is equal to work, we already found to be negative 2, over distance, which is 5. So force is equal to negative 0.4. But since they only asked for magnitude, magnitude means we don't care about the sign. So it is just 0.4. That's it for question 21. On to question 22. A rubber ball of mass 0.8 kilograms is bouncing off a rough floor. When it is about to hit the floor, its speed is 3 meters per second, but just as it bounces off the floor, the speed is reduced to 2.6 meters per second. The kinetic energy of the ball as it hits the ground, so half mv squared, we're going to use the same rule, half times mass, we already know is 0.8, times kinetic speed directly before it hits the floor. So when it is about to hit the floor, it is 3 squared. So if we do this on the calculator, we're going to get half times 0.8 times 3 squared, which is 3.6. So that's it for part A. For part B, we're going to do exactly the same thing. Half times mass times v squared, half times 0.8, which is the mass, times velocity after it hit the floor. As it bounces off the floor, it is 2.6, so times 2.6 squared. If we do it on the calculator, we're going to get 2.7, which is our answer. And now for the last part, as we said, work done, work is equal to KE final minus KE initial. And we already got, as it leaves the ground, which is final, 2.7, and the initial is 3.6, so it is 2.7 minus 3.6, which is equal to negative 0.9. And that is our answer. Question 23 now. Underline the unit that is used to express work. This is just memorization. It is joules. Work is a scalar quantity. It can be negative or positive. This basically means work doesn't have a direction. It could be right, left, up, down. It's just memorization. Work does not have a direction. You need to memorize these. Question 25. Two bodies P and Q form a system. After some interaction, Q has lost 80 and P has gained 60. Now in this case, they didn't tell us that it is an isolated system. So we are going to write down Q plus P is equal to something. We don't know. They told us Q lost 80, so negative 80, plus P has gained 60, equal to negative 20. So we're going to look now at our options. Body Q has gained negative 80. This gain negative means it has lost. So they already told us it has lost 80. So gained negative 80 is the same as lost 80. This is correct. The system has gained 140 joules. This is wrong, as we just saw. The system has lost negative 20 or gained. No, sorry. Yeah, it has gained negative 20 or lost 20. These are the only things that happen to the total system energy. So gained 140, this is wrong. The system has lost 20. Yeah, it gained negative 20, which means it lost 20. This is correct. System is isolated, wrong. If it is isolated, it would have been 0. There's no gain and no loss. But we got negative 20, which means it is not isolated. The system has gained negative 20, which is the same as the system has lost 20. So this is also correct. So this is it for question 25. On to question 26 now. Two bodies P and Q form an isolated system. Which statements are true? Let's read them one by one. Energy gained by body P is equal to negative energy lost by body Q. Now, if you think about it, this is just not true, because energy gained by P is going to be equal to the energy lost by Q, not negative. So if P is 60, and we said it's an isolated system, so it has to be 0. So if P, let's make this P and this Q. If P gained 60, Q has to lose 60. So the energy gained by body P is equal to the energy lost by body Q, not negative. Because if it was negative, then it would be 60 plus 60, which is 120, which is just completely wrong. It's supposed to be 0. So that's it for the first one. Now for the second one, energy gained by body P is equal to negative energy lost by body P. So basically, if we're saying energy body P gained positive 60, it lost negative 60, right? Sorry, it lost 60. So that means that energy lost by body P is 60. Energy gained by body P is going to be 60 as well. So 60 is equal to 60. This is correct. Energy gained by a body is equal to negative the energy lost by the body. So negative the energy lost is the energy gained. Like, it's just playing around with the negative sign, which is a bit confusing. Energy gained by P plus energy gained by Q is equal to 0. We already said that an isolated system, energy gained by 1 plus energy gained by 2, it has to be 0. Energy lost by P plus energy lost by Q is equal to 0. These two are basically the same thing. They have to add up to 0. Energy gained by body P is equal to energy gained by body Q. This is wrong, because energy gained by body P has to be equal to negative energy gained by body Q. They are opposite. So I hope this question is clear. I know it's a bit confusing, but just think about it logically, and it's going to be simple. They just play around with the negative sign a lot. Now question 27. A 0.1 kilogram box is lifted from the ground and placed on a shelf at a height h as shown below. Assume g is equal to 10. The work done, okay, we're going to use, w is equal to f times d. W is equal to force. So they already told us that now the force acting on this is going to be gravity, right, or weight. So as we said before, w is equal to mg. So it is mass, which is 0.1, times gravity, which is 10. So force is going to be 0.1 times 10, times the distance it traveled, which is the height we're looking for. So we're going to end up with an equation that says work, and they already told us here, by the way, work is 1 joule. So 1 is equal to 0.1 times 10 times h. So if we do this on the calculator or just mentally, it's very simple. 1 is equal to 1h. H has to be 1, which is our answer here. Or I believe we could use work done by weight is equal to mgh simply. And they told us that the work done by weight is 1 is equal to mass, which is 0.1, times gravity, which it told us is 10, times height. If you don't want to derive, just memorize this rule. And here we are also going to get h is equal to 1, which is our answer. On to question 28. Select the cases in which the body is gaining energy. So it's going to be the cases where the direction of motion and the force are in the same direction, which is this case. Here they are opposing, so it's not gaining. Here one is up and one is to the left, it's not gaining. Here one is up, one is down. In fact, this is resistive because one is up, one is down. They're resisting each other, so it's resistive. So the only one motive here is when they're both in the same direction. Question 29. Losing energy, so basically resistive. they're both in the same direction. It's gaining. It's positive, so it's not losing. Here, direction of motion and force are opposing each other, so it's negative. They're losing energy. Sorry about that. For the third one is up and one is to the left. They're not opposing and they're not leaning, so it's neither of them. It's not motive nor resistive, so it's nothing. It's wrong. It's not losing energy. And for the last one, it's one up, one down. They're opposing each other. It's resistive, so it is losing energy. So that's it for question 29. On to the last question. The work energy theorem states that the net work done on a body equals the change in its kinetic energy. This is just pure memorization of the work energy theorem. Anyways, we are done with the quiz. I hope it was clear, the explanations were clear. If you have any questions, please don't hesitate to contact me or anyone on the QST admin team. Thank you for watching the video. Good luck in your exams, and bye-bye.